Hello, everyone again. Thank you for joining for our weekly machine learning study jam. And today we're going to continue with computer vision, introduction to computer vision algorithms. And I hope you can see these slides. We'll start the slideshow. So today we're going to have the introduction to convolutional neural networks. And so last time we trained our model to recognize shoes in the built-in dataset. We had the shoes depicted or represented as pixel integers, and we labeled the shoes already. So this was the labeled dataset. Then we trained the model to guess the integer value or the output. For example, these shoes belongs to the 9th item or the 9th type of the fashion item. But the images in the training dataset had some limitations. One is the image should have only one object, and furthermore, the image should have been centered. So if you do another test on the algorithm that we've had so far, that we built last time, and test it on different data, for example, like this or any other data, the recognition percentage, the accuracy will be lower because the machine haven't trained to do the recognition on other items, right? And that's where the convolutional neural networks can help us. So the concept of convolutional neural network lies in that we put the filter on images before training the deep neural network. And filter is just a set of multipliers. So for example, we take the pixel, and this is the numbers, right, of the pixel. The current pixel value is 192, and we have the corresponding filter box here in the red. So what we do, we multiply the current pixel to the corresponding filter value, and we do so for all the neighboring pixels. So here is the defined current pixel value, 192, and we calculate the new pixel value by multiplying the current pixel value by the filter definition, by the filter value, and sum all the transformed pixel values of its neighbor. So here is the sum of all filtered pixel values. If you have any questions during the presentation or during the coding, please don't hesitate to unmute yourself and ask questions. Or if you have more experience in machine learning and I have some mistakes, don't hesitate to interrupt and correct me. Now, let's see the examples of some filtered images. So this is our input, the image of a staircase, and we applied some filters, and this is what we got in the end, in the output. This is the filtered image, which removes everything, and the vertical lines only will remain here. So we see clearly the vertical lines. Then if we try to apply different filters, then we see here that everything has been removed and the horizontal lines are more prominent here. Then what we do after filtering, we apply the pooling. The example of pooling is the max pooling 2 by 2. So we saw previously the current pixel value 192, and this is the array of pixel values. And what I mean by max pooling 2x2 is that we reduce our image by 2, and then we take the maximum value from this reduced image size, right? Now 192, 144, 255, 168, and then combine this to get a new pixel values, a new image, which is reduced by quarter from compared to the original image. So this is what max pooling 2x2 means. Max is because we chose the maximum values, right? And 2x2 because we divided the original image by 2x2, okay? And then what we do is, what we should understand is where these filters come from. So we already know that we need to apply some filters, and based on the values in these filters, we get different filtered image, right? What it does is when we run our algorithm and give the algorithm an input, it will apply random values and the features, and then it will go through these layers and choose the most accurate value from the training set. And this is how we choose the features. So this is how the feature extraction occurs. And the example is the code that we used in the last study jam. So we defined our model, and the basic model type that we used is sequential. And we had the input, the first layer, the flattened input, which we parse into the next layer, dense layer. And then this layer was parsed into the last dense layer, which was our output. And here is the code we used in the previous study jam. And this is what we do to include the convolutional neural network part. So it looks same, right? Here we have the deep neural network code. Here we define the layers, 2 more layers. One is the conv2d, which is required to specify the input shape. And for those who are new to the study jam and who wasn't present in the last study jam, the input image that we used was of 28 by 28 pixel size. That's why we define here these numbers. Then 64 is the number of these filters that we're gonna use. And we perform the max pooling 2x2. So we specify a layer which will do the max pooling 2x2. And you can actually add more convolutional neural networks layers, just stack upon one each other before the deep neural network layers. And it will help you to get your algorithm trained by really log pictures. So instead of training from the labeled data set, for example, you have the pixels for long sleeves, then this is the shirt, and if it's a short sleeve, then it's a t-shirt. Instead of that, you just reduce the image that much that it's super difficult to understand what the image is, but the algorithm will try to extract as much features as possible to classify the training set. And maybe that's it for the presentation. So let's go to the practice. We have here Abdullah joined as well. And I just explained the topic. I don't know where you joined, but we will still do some practice. So don't worry if you haven't heard everything. So this is the web page this is the code lab that we are going to do right now. Please go to this web page, and here is more detailed explanation of the convolutional neural networks that I have explained so far. Here are the links to the 2 previous code labs that we've done before, if you want to do. And you can also open the collab as well. So this is how your page will look like. This is where you can run your code and see the input or the output. Okay. And let's go to collab. So we proceed further. I give you maybe around 10 minutes to read and understand what was written here. It's actually what I have already explained to you, but maybe you need some time to comprehend it. If you're done, let me know. I'm going to add some information about this page. Perfect. Okay, so Abdullah and Remy, John. Okay, so you're done. Okay, so as I already said, the image data set that we used before had the single image only. It was centered. It was like the basic image in the training set. But what we are learning so far is just the basics, the introductory course. And imagine you are having a different task. You have a research project or another pet project that you are going to do, and you're going to extract some images. And usually we don't see such kind of images, right? There is always at least a leg, for example, if it was a shoes data set, or the background would be different, not just blank white space. So this is where we should understand why we use the convolutional neural networks. We want to remove unnecessary parts and only extract the features that are relevant to our aim, to our goal for object detection, right? And this is the page which explains, okay, I have already opened, the built-in picture that we're gonna use today, the staircase picture, and how we should import the library, how should we save the picture, okay? What we should notice here is that the shape is 512 by 512, and that's it for now. So this is the library that you're gonna use today for a data set. And last time we used the fashionista of TensorFlow, I think, built-in dataset. Let's go to the next page. And by the way, everything that we do are aligned. The information is aligned with the collab. So here is the explanation of the limitation of previous deep neural networks that we used before. This is the example of image that we could get to classify, and we could have some problems because there are so much in the image. And this is how we process, how we filter the data using the multiplication of the current pixel value by the filter. Okay, let's go to the code lab. Now, what we're gonna do is we're gonna try to code our first convolutional neural network together. And first thing first, we need to import necessary libraries. So we saw before that we use the convolutional 2D layer. That's why we import this one. As well, we need the NumPy library because our picture is represented as an array of pixel values. And we import the SciPy mist. This is what the picture comes from. This is the source of our picture. And we save it as I, okay? Then if we want to look at the picture we are now working on, then we need to import matplot library pyplot and use these commands to see the picture, to visualize it. Then what is easy with this data is that our picture, as I said, is a NumPy array, and we can copy it by just using the dot copy method to get our image transformed or filtered later on. And we need to extract the size of an image because we're gonna iterate over the image X and Y axis to get the pixel value and to apply the filter on it. If this is easy to understand, then let's go to the collab and run our programs. And there is no environmental setup, I think. So we just need to start running our code. And if you got this message, then you need to press run anyway. So this is the same code that is in the collab. We should wait until all libraries are imported. So we could see here the tick sign that everything is set up, or here. Now we visualize the image that we got. So this is the image. And we copy this image to the I transform. So the image now is saved in I, and we copy it by np.copy and get the size of an image. So everything now is set up here. Now let's go to the filtering process. Let's define the filters ourselves. You can see here there are some commented filter variables defined. This is because actually you need to play around with the filters and see what works best for your data set. As we learned in the first study jams, the machine learning has the scientific mindset. So what we do always is what we do experiments. And if this filter doesn't work so much, then we can try another one and another one. What works best for you? You can run the default filter right now, but if we have some time, we will try another filters, and otherwise you can do this. You can do this on your own, okay? And we need to define the weight, because this is now the weight is 1, but if you define the filters by any random numbers, make sure they are equal in some when you sum up, it's equal to 0 or 1. Otherwise you will need to modify the weight to 0.1 or other numbers to get the sum of 0 or 1. So let's run this code. Okay, it's already done. Now let's do the feature. So let's apply filter on the image. So previously we extracted the size of a data image that we got, the staircase. This is the size X and size Y. And we go through the image using the for loops. Some of you might not be familiar or not so confident in coding with Python. So that's why I explain as much as I can the details of the code. So we go through the X axis and Y axis. That's why we have a nested for loop. And we define the convolution with 0. So we just initialize it. And then for each pixel value, we add the convolution. So we sum up the convolution value, which is modified by the filter value. And you can see here, the pixel is taken by, so I is our image, and X and Y in the I is the pixel value, right? And we take all pixel values from X minus 1, Y minus 1, and all different combinations of the direction where the pixels are located. And according to the pixel location, we extract the filter value as well. So filter is now defined by the 3x3 matrix, and we take the appropriate item from our matrix based on the location of the pixel value in the image. And after that, after we done this, we multiply the resulted convolution. So every time you calculate it, you know that the value that you calculated will be add up, right? That's why we have here convolution equal convolution plus. So after that, we just have the convolution value updated. So instead of 0, it's gonna be from 0 to 255, any number in this range. And then you multiply it by weight, and the weight we already defined here by 1. Then if the convolution end up less than 0 or more than 255 by any case, then we just define convolution equal to 0, otherwise equal to 255. And we parse this value, the filtered value, to the I transformed image. So I transformed image is our image that we copied from the original I image, right? And the X and Y values will be updated because when you go through the nested loop, you first go through the first item X, which is equal to 1, and you go through all Y items or values in this range. So from 1 to the end of the picture. And you can imagine that here at this line, you will get every Y value for a given X, which is 1. And then when we complete this inner loop, we go to the next X value, which is 2, and calculate all Y values to X and Y values to the transformed image. As a result, we should see our, maybe that's not the, so here is only the calculation. If we want to see the transformed image, we will use the matplotlib library that we already imported to see the transformed image. So this is the transformed image. Compared to this, it's much more, we surely see it's filtered, and the more vertical lines are apparent here, right? Now, we can see in the examples here and in the examples from the presentation that based on the filter values, you can get different results. Maybe we should go to the, yes, maybe I should have explained here. So this is the same code that I explained already. We can go next and just examine the results that we got. So this is what we do in the collab and in the practical, this web page. So what we should understand from here, that we should experiment with the filter values. So here the result that we got from using the filter matrix -1 to 1. And this is another example. So here we can try and just uncomment and try different result. So let's see. Yeah, so here we see super blur image. I think what it helps us is it helps to train the model to recognize some really important features like this, for example, or like this from an obscure image, right? We can try other filters as well and see the result of the filter application. Yeah, so here is, okay, let's try. Yeah, so here I clearly see that the vertical lines are more prominent. Maybe this one as well. So let's go to the next section, is the final section, pooling. And let me see the code lab. Please read this section yourself to understand better. I'll give you about like 5 minutes, and then we'll go to the code. not that much to read here. If you're done, let me know and I'll explain, add more information or emphasize what you should what are the main takeaways from here. Okay, and so what we've done so far is we applied the filters. It helps us to identify the key features or blur the image so much that the algorithm should really learn from the blur image what is it, right? And pooling helps us to reduce the image but leave the features only. So when we do pooling, here is the example of max pooling 2x2. We reduce the size of an image by quarter, but the features are not only remained, they are emphasized. And if you are familiar to image processing, you know that actually the pixels can be represented. So here what we see is that we can represent like a pixel by this matrix. But what we do here is we combine pixels and we take the maximum because this is a max pooling. And then we combine these max values to another matrix. And it's kind of combining the neighbor pixels into the one pixel. So we reduce the size, but we enhance, we take the maximum pixel value. So our features must be enhanced from this procedure. Okay. Yeah, it's like binning. Yeah, I think it's related to the binning of the image, the size of a bin. Maybe some of you have an experience in microscopy that can help to understand what we do here. Okay, so let's go to the pooling code, and the same code is presented here as well. So you just can read it from here or from here, but this is more fun way, practical way to run code, to edit it and see the result. So how to write the code for pooling? We create new X and new Y, which is the new size parameters of our image, because we already know that the size will be reduced, right? And we know that it will be reduced by 2 from X and Y axis. That's why we take the original size X divided by 2 and we do type conversion because the size could be an odd number. So when you divide by 2, there might be some remainders, but we take the integer and this will round number to an integer. And we create the new image array. We use the .0 method to create an array of zeros. So we populate our array with zeros, and the size is specified by these parameters, new X and new Y, that we have already calculated. And again, we will have a nested loop to go through the X and Y axis from the original picture, right? So we use here the size X and size Y. And we create, each time we create an array, and this array will be appended, or the values will be added based on the transformed image we got from the convolution step. And it will take it will take values only from the how to say, from these 2x2 boxes, right? So that's why we have here y transformed x plus y, x plus 1 and y, x, y plus 1, and both x plus 1, y plus 1. Then we sort it to reverse order, and we add the values that we calculated, the pixel values that we calculated, to our new image. So instead of zeros, now we will have the pixel values. So the image, new image x and y are going to be x divided by 2, y divided by 2, and pixel 0, which means the pixel first item. Okay, and if we run this code, we already see here we can plot our image. This is the result of our pooling procedure. So because I had used different filters, we can see clearly that after pooling, the features are enhanced, right? Here is already enhanced features, but by pooling, we reduce the size and make the vertical lines more prominent. And this is the end of this code lab. Actually, it was quite fast and maybe easy for you, I hope to understand. And this is what we've got. And in the next final step, we're going to introduce these convolutional neural networks to our first algorithm and first data set that we have used, the fashionist. To, instead of using the deep neural network, we will add the convolutional neural network. So if we look back to our data set, so this is the fashionist data set, and what we have here is we labeled our data set, but now we're gonna parse the data into our algorithm, and using the convolution and pooling, we will extract first features and then enhance them, and then do the deep learning stuff. So as I explained in the presentation, the convolution layer, the max pooling layer will be first, and then as usual, you will parse the deep layer or the dense layer, the flattened layer, the dense layer, and the output dense layer. So maybe it's better to understand here. So instead of this code, we will have more layers, 2 layers at least, 1 layer at least, 1 layer of convolution and 1 layer of the pooling at least, but you can add more and more. So this might be useful, for example, when I used the features, I think the first one. Yes, maybe the first one. It was more blur. And if I add more and more convolution layers, then my picture will be more and more blur, and the program should learn how to extract the most prominent features from this blur picture. Let's see the result. Yes, so it's still working. So we see here the vertical lines, the staircase are clearly seen. Okay, do you have any question? And by the way, this one, the first Hello World in machine learning, is also run in the collab, so you can run it here to see how we've done the deep neural network last session. We imported the TensorFlow, the data set, defined our training images and labels, and test images and labels. This is for visualization. This is how our images looks like pixels, right? That's why we use the for loop to go through X and Y direction and to update each pixel value to a new value using the convolution. And then we take like the range of, for example, the first 2 by 2 box and take the max value, and this will result in reduction of this image size, the array, by 4. And then we train our data, define the training our data, defining our model. When we define our model, the training is run by compiling. So we define the epochs, which is the number of cycles, and then we can, after we trained our data, we can test it with our test images. Okay, if you don't have any questions, I think that's the all for today that I wanted to explain. If there are some questions, I'm happy to answer, or at least try to answer. If everything is clear, then would you like to give me a feedback? So after after the next session, so it's going to be the last session on the so we're going to apply the convolution and pulling onto the fashionista dataset, this dataset, and see the result. And then we will go through the machine learning crash course again. We will continue to the topics we have stopped for some time. And if you want to learn particular topics, you could share with us, for example, what kind of problems or what kind of algorithms you would like to learn. I'm also thinking to have one session about finding the data set. For example, after these 3 sessions on basic introduction to computer vision algorithms, what you can do is you can define a problem. One problem is how to get the data, and you can do web scraping. So we can learn how to web scrape the particular website to get some images, or for example, how to use the already prepare data sets, like in Kaggle, for example. The most famous is iris, plants, or cat and dogs, and then apply these algorithms to the new data set and see the result. And if you would like to do this, I'm more than happy to prepare the study jam on this topic as well. And otherwise, I'm open to any suggestion. What would you like to study? And hi, Angelo. I think you might have joined recently. So we actually finished the main thing for today. We've covered the introduction to convolutional networks, and we've done the lab. So if you haven't seen, I recommend you to study this code lab and do practical activity on this collab session. If you have any ideas about the topics, this is the perfect time to share. We used classification. So Dev asks, so we use classification model predict test images in last class, and can you explain what this does? Okay, let's see. By example, so here. Yeah, so we've trained our data and then we parse it in new images different from our trained data. And then we evaluated how good our algorithm works on the new data. And actually, we can see here that the accuracy of our algorithm on training data is not that great. I think I don't have much experience, but I think having almost 90 is, maybe it's good, but I would aim to try a better solution. But when we parse in new data, the training is the accuracy is almost same as the training data. So we've done a good job. Our algorithm can recognize or label any type of fashion clothes to the right label with almost 90% of chance. And then we use the predict function, which is used to actually receive the label. So here we evaluated our model, but here we provide the test image to our model and use the dot predict method to get the label of the new data. And when I run it, I can see that it first gives me the values. So maybe you remember from the last time, it calculates the, how to say, maybe so-called probability that the test image belongs to one of the 10 types of the fashion clothes that we have. Let me remind you that we have here 10 types of fashion clothes, and here the array consists of 10 doubles, which are so-called probabilities that test image belongs to either of these data labels. And what our machine does is, what our algorithm does is, it will choose the maximum number, which is in this case, is this one. So it predicts that our test image belongs to the 10th data type. In this case, it's ankle boot. And we know that it's correct because the test image, if we print it, it is 9. We can see that the test label 0, which means the test label of the test image is actually 9. So it predicted the label correctly. Do you understand? Okay, thank you for the question. Any other questions regarding previous or today's session? I recommend you to not only run these codes, edit them. For example, last time we changed the number of these values, and they explain what happens when you change these numbers and why some numbers shouldn't be changed or couldn't be changed because your program will not work. And moreover, you should do the exercises to get more understanding of these algorithms. There are 8 exercises. And if there are no questions, then this is the end of our study jam today. And then I hope to see you next week. So I will end it now.